Hey, grade six. So this is just a little bit of a review and some strategies for those people who are still struggling with input-output tables or input-output machines. All right, so just as a review, right, our input-output machines, we input a value, it undergoes an operation, and then after that we have an output, right, a changed numerical value. Most often it'll be changed based on what's happening on the inside. So what we have is an input-output machine, right? It's used to make a growing pattern. Okay, growing a pattern would just mean that it's increasing in regular intervals, right? It's not random like a pattern is, right? In each input, it is multiplied by 9. As you can see here, we have multiplied by 9 to get an output. So what that means is if you have the input of 1, so we put 1 in this machine, it's going to be multiplied by 9, and we're going to equal very long equal signs 9, right? So how we represent that is in a pattern rule. This is what we really need to know about this slide. The pattern rule for the output's here in the same color, would be is you start at 9, do a little 9, you start at 9, and then you're going to add 9 each time. We know that because we can see what's happening from one frame to an X, right? What's happening between here and here is you're increasing it by 9, right? So that's our rule. That's the most important thing from this slide, is you have values, you input a value, right? Something happens, and then it outputs. And you can have a pattern rule for the input, you can have a pattern rule for the output. You can also have how it relates, right? So how does the input, right, which we have here, sorry, the input relate to the output? That's kind of important. This one's also important. Okay, so sometimes we have machines that have not only one but have two equations, right? Two things that kind of happen to it, manipulate it. So once again, you have the first value. You have 20. You put it in. 20 divided by 2 is going to be 10 plus 3 is going to be 13. Okay, so what's really happening is the input is being divided by 2, and then you're going to add 3. So if I ask you what the pattern rule is for how they relate, this is what you need to have, right? So in this case, it'd be divide by 2 plus 3. Divide the input by 2. That's a lot of highlighter to the point you can't even erase it. Here, read it. Divide the input by 2, then add 3. You can use this rule to predict anything, right? So if I said, for instance, the input was 70, you divide by 2 as you have here, and you're going to add 3, and it'll give you your output. Okay, so these are rules. And it's kind of introducing what we're going to talk about in topic 4. So some strategies to solve. What we have here in this corner here, the most important thing is these are some strategies we can use. We've talked already a little bit about using a pattern, right? You can make a table, right? We have a table right here. That's the example of what you can do for that. This might work for some people who are a little bit more organized, right? You can solve a simpler problem if that exists. We're going to talk a bit about guess and test today. That's when we're going to talk about more. Or you can kind of develop your own pattern. You can even draw it out, really, right? Whatever really works for you. That's me writing the word draw in case you didn't know. But anyway, this is our thing right here. Ben made an input-output machine that uses 2 operations. Here's a table for Ben's machine. The table is going to be, if you haven't put it together, right here. This is the table we're manipulating. So the first thing you should do is write down what do you understand on all questions. Like, what do we know, right? So what do we know? That's the number one thing you should put. But the first thing we know is that the machine uses 2 operations. So you're going to draw above your table, right, 2 different squares, because we know it uses 2 operations. That means 2 things are going to happen to it. Either addition and subtraction, division and subtraction, multiplication and addition, whatever combination, but we know it uses 2. We also know that the input starts at 2, and we know that the output starts at 13, right? It's just helping us understand, then we can investigate how are these 2 related, right? How are these 2 values related, so we can start figuring out what these operations are. Well, that's supposed to be a question mark, and I really messed up. Whew. It's tough enough to do question marks, I find, But when you're using a trackpad, I almost bought a mouse today, and I should have done it. Anyways, right? So what we're going to do is we're going to start doing the guess and test method when we get to our next stage, which is really the planning. Right? Think of a strategy to help you solve the problem. So what you're going to do is you're going to go through these, you're going to figure out what works best for you. Right? We're going to show you the guess and test method. Okay? So let's start first by a little bit using the table to solve the problem. So what we're going to do is we're going to look at the input, we're going to look at the output, and what's happening between each line. So what's happening from here to get to here. And what we should know is that we're adding 10. Adding 10. Right? When we go from here to here, my arrows are not good today. You're adding 2. Right? And you can continue this pattern, and it should be consistent. Right? Same here. Same here, right? Is under each line, you're adding 10. So when the number increases by 2, the number being the input, the output increases by 10, all right? So you can kind of start guessing what can happen, but what we're going to do then is we're going to say, all right, we know that what happens is there's a relationship between 2 and 10, all right? So let's keep going through. So we know what's happening to the input in order to the output. Next, we're going to try to solve, right? So the first, remember we talked about the first method we're going to do is try guess and test, okay? So if the output is increasing by 10, we know this from the previous step where we're starting to plan. This suggests that the numbers are multiplied by 10, right? If this is increasing by 10, we're assuming then that this number is going to be multiplied by 10, right? That's what we're assuming. But 2 multiplied by 10 is 20, right? We need this to equal to 13. Okay, we need this to equal to 13. So what we have to do is we have to subtract 7 to get to 13. So right now we have input, right? We have multiplied by 10 minus 7 will equal our output. That's what we're saying is a rule. And now what we all have to do now is put in the input, oh sorry, zoomed in by accident, input values and the output values, and this should hold true, right? So let's try it. We just tried it up here. We know it worked for the top one. Let's try it for the next one. I'm going to go bring this up here. We'll have 4, because that's our input value, multiplied by 10 minus 7 should equal to 23, right? But it equals, and if you're following along, 33. So we know that this does not work, right? We guessed and tested, and it's wrong, okay? So what we have to do is we have to try another pattern, all right? We have to try a different pattern. So once again, the input is increasing by 2. We know that. The output is increasing by 10. Okay? We're looking here. Right, that's 10. Increasing by 10. Finish that. Okay? So then if it's increasing by 2 and increasing by 10, it's safe to say, remember this is equivalence, right, that if we're increasing by 1, then we're also increasing the output by 5. Okay? So if these two are together, then it's safe to say that these two are together. Okay? So this suggests that the pattern involves multiples of 5. Multiples of 5 meaning multiplying by 5. So let's try that. So maybe our pattern is going to be input multiplied by 5, and then we have to do something, right? So 2 multiplied by 5 is going to equal 10. Right? We're not there yet. We add 3. do that. But that's going to equal 13, right? So we know that we have to add 3. And that's going to equal your output. Now let's see if that works, because it didn't work last time. Right? We're going to rewrite this, but we're going to do it for 4. So we have 4 multiplied by 5 plus 3. See if it works. Okay? So right now what we're doing is we're checking to see if the rule is correct. Okay? 4 times 5 is 20, plus 3 is 23. Okay, so we guessed, and we tested, and we found that it's right. Okay, so these are just different strategies. You could just continue this table, right, and that would have helped you found it as well. Or you can start building what's called an equation, and this is what we're going to learn today. All right? If you have any other questions about this, feel free to ask, but this is basically it. All right? This is basically the start of everything. All right? Have a good day.